Good morning, everybody. Thanks for coming a bit earlier than usual today. I wanted to get as much as we can and also get a chance to watch a video. And so that's why we needed to start 10 minutes early. And so thank you for making the time. I know if you have to leave, you can leave by the time you need to leave. That's perfectly fine. And what I would like to do today is finish up a fairly big topic that we started and spent 2 lectures on before, and plus the guest lecture we had. And this will be the 3rd and final one. And I wanted to give it a name. And so one thing that I said was leftover topics. And I wanted to call it, you know, if you have something left over and you warm it up in the oven or something, you get some kind of soup. And I was going to call it data visualization soup, and that didn't sound so good. So I called it wrap up. And so basically what I really want is point you to some pointers, that's funny. So the resources, and then things that I didn't get a chance to look into, we would look into them. And then we will, I will talk about an assignment towards the end. Because you're coming now, and I said eating breakfast during the meeting is fine. Oh, by the way, I did that survey, and almost all of you said you can make it. That's why I decided. And there were a few who couldn't, but that's okay. There will be a recording. And when I had the survey, I wanted to drop a note for you if you like how things are going and things like that. And the first time I did it, you didn't even see a chance to fill it, but we'll get the chance to have feedbacks like that on another occasion. The purpose of the survey was to find out time. If you are curious, 99% of the class wanted to meet at 9 today. So that's why we are here. And so since I said we will be okay to have breakfast, you can turn your cameras on. My warm-up question for the day is going to be, what did you have for breakfast today? Or what are you having for breakfast today? And Kati will be the person to write today's warm-up question. I didn't even say hello to everybody on the chat session today. We want to just write it started. Kati, when you're ready, please go ahead, write the warm-up question for the day. What did you have for breakfast today? Or what are you having for breakfast today is the question. And I'll let you know what you say. You guys can see what you have. All right, I'm going to start now. And for the purpose I have now, these slides are fine. And they are posted if you really like to follow along on Blackboard. It's just a PDF version, but I would rather have you here and follow me along. And I'll try to finish this thing in time, so we have time for the 15 minutes or so video I would like us to watch together. And I want us to have 5 minutes or so to come back and talk about it and relate it to what we will be doing. Okay. I'm going to start with a little bit of kind of give you an overview. And what I want to do with this is, if you know, the last lecture we had part 2 focused on design. So there was color and things like that, but it was data visualization and design aspect of it. There is another one that I mentioned is in the syllabus, and this kind of the topics I want to touch here, and especially for people who have interest for pointing out to things that could inspire project ideas. It's organized more or less like a 1 lecture, 30 minutes version of this book that I told you last time, Visualize This. It's a popular book. It's not like a textbook or anything like that. You can spend an afternoon or a couple of days to go through it, and you will get enough things out of it. So this is more like a 20 minutes digested version of it, plus whatever it is that I wanted to add. That's why I have added as a reference at the bottom what this book is called. And this is somebody who has a PhD in statistics, but got very much into data visualization and has the flowing data company and a website and things like that go along with it. So there you have it. So I'm going to maybe first talk about a little bit of general things, especially around data. And then I'm going to come back and talk about kind of a follow-up on the very first lecture we had on basic principles for visualization and what sort of things you could do. Very practical type of thing. And I'm going to wrap up with how you can visualize text information. And spoiler alert, I'm going to talk about assignment 4, and it is going to have something around visualizing text. And I'm going to spend a little bit of time telling you what assignment 4 likes. Your past weekend was assignment 3. This one, no, it's not. You will have an assignment to do. Okay, people, as I said, visualization is very big and it is effective. And there is so many other things that can come in other than data visualization. For the purpose we have in this class, we focus on data visualization. We wanted to make the data that is needed to be visualized in a manner that provides insight, asks people to call to action, communicate something effectively, persuade, this sort of things, right? But there is also other things than data that needs to be visualized. The Iraq war example, the data that I showed you, has got data, but there was something artistic about it and so on. But there are other things too that are not numbers, and so data scientists and journalists together, like that type of combination is a field on its own. People in art, and I'm going to tell you a couple of things that you probably haven't come across, but will be good to know, is an area where visualization plays a big part. And so it's not just numbers. Entertainment, this class and this generation doesn't need any preaching from me on what role of visualization in entertainment. You can find almost anything that you can think of, including, how video games work, or how things that are animations work. I remember attending a conference many years ago, computational mathematics and science and so on was what the conference was, and the guest speaker was somebody who produces animations. And if you would really like to know, there is lots of interesting, very, very cool math and modeling that happens for those animations to actually happen. Very, very nice ones, graphics and things like that. So the entertainment industry is big, of course, we know that, but there is, for those of you who really are curious, where your skills could be used, there is a lot of interesting deep things that happen there that you don't see. What you see is what everybody sees on the screen, and it's all cool, but there is a lot of math, there's lots of data science, there's lots of modeling and coding, of course, and things like that happen there. And so visualization is relevant there, and you really want to make something compelling. Compelling doesn't necessarily mean complicated. In fact, it is quite the opposite most of the time. What to look for: patterns and relationships. This is probably a good kind of 2 keywords to say there. Design, we spent some time talking about it last time, but these are kind of basic things that you remember. And so think of these bullet points as reminders for yourself for whatever it is that you want to do. You'll never forget to label accesses. Otherwise, Helen, when she grades, she will say, oh, you took a point out of this one because your accesses were not labeled. You're having nice encoding, blue means this and orange means this, but if you don't tell me what those encodings are, they're not going to be very helpful. Similarly, other things, other encodings, and there will be more and more things that you would encode, both with color, with shape, with other things that you would do that are included in your visualization in a thoughtful way, but they need to be told to the audience. They need to be explained. The keep your geometry in check is a reminder for what I told you. For example, when you use bubble charts where you have, data points in a 2-dimensional space, and you also wanted to say a third thing, and so you use the size of the bubble to show that. And if something is doubled, remember what is doubled is the area, right? And if it is a volume, so keep your geometry in check. These are reminders. Include your sources. It's very easy. I do that sometimes, very, very rarely. If I have a presentation like this, I forget to where I got it from. But if you have something to communicate, whether it's publication or other things you do, please make sure that you include your sources, not just for credit, but also in defense of yourself. And consider your audience. Offer made this point last time: when you do data visualization, just as much as you think about your data, just as much as you want to say, I have understood this, and I'm saying, you should also think who is seeing it. And so you've got different ways to do it. If you are doing a nice poster to inspire high school students to do data science, you have a different approach. You will do a much better job on that than I would do. And if you have an audience that is very interested in your machine learning model and all they care about is the parameter used and that type of thing, the audience there will be different. That was a bit of an exaggeration what I just said, but you would know. And that is a serious consideration. And just as a side note, we are not very good in academia when we talk about our work to other people. And if you really spend a lot of time trying to communicate a very small, tiny fraction of the entire population, of energy, your creativity is spent there, well, the vast majority could have benefited from what you have done. That's a lost energy, in a way, lost, time in some sense. And so it's good to consider your audience and try to reach out to as many as possible, especially if you have an important message to send around. The video, by the way, has got a little bit of connection with what I just said now. Okay, this is not going to be a tour on handling data. We had, if you needed a reminder, and it's okay if even if you haven't turned on your camera, it's okay for you to sip your coffee right now, and you can still turn on your camera if you're sipping your coffee. We are on week 5, I think. Week 5. Data visualization is what we're covering. The week before that, we were talking about data wrangling, right? There, we did cover quite a lot of things. Assignment 3 has also given you a chance to work with it, dplyr and things like that, right? So they're coming from different sources. Sometimes you have to deal with formats and so on. So that is a non-trivial thing, and that's part of the thing that I wanted to talk about now. But some of it is also about finding the data that you would need for the kind of things that you would work. So gathering data, you know, all Google, search engines will be your sources when you want to find. Sometimes you have direct sources, and I have a good number of them now, not to go through them one by one, but to show you that they exist. And these days you will be increasingly surprised that there are places whose sole objective is to provide data sets. And thanks to people who have pushed for things to be freely available for all kinds of reasons, there is more and more of it. And so there are direct sources, and universities are good places. People who have done machine learning type of work would know some university names where they have made a name for themselves because of the data they make available, and everybody, when they write their papers, would cite them. Back in the days when metrics, algorithms, and so on were important, there was a collection. At that time, the person who was doing that collection was at the University of Florida. So he had a nice sparse metrics collections, and it grew and grew and grew and became a community in a way, because they would go look for a metrics that is challenging, that has got some special structures to it and so on. So universities in some cases, especially for some select areas, will be a good place. But generally speaking, they are a place to go to. That was gathering, and then formatting data is an issue because people would put things in different ways, and there are some fields in which standardization of how they should be, data should be, is a big deal. And maybe one of your contributions could be to come up with ways in which you can standardize. I know people in geology, or sometimes in some agriculture, or even in biology has got plenty, and there is also all kinds of standards, and it has got probably a leg up in terms of starting early compared to other disciplines. But there is a room for coming up with good ways to standardize and having two data formats and things like that. Okay, I'm going to walk through now, and this would have been a place, if we had plenty of time, if we did not have a video to watch, that I would have, make you click on this one and point a couple of things, and I could have asked Chris's help to do that. But I think that's probably not a good use of our time. So I'm going to invite you to go through these things later on your own. Most of these ones, I collected them a couple, maybe I've revised them, but they are a year or two old. And so I know most of them still exist, but if a link is broken, don't blame me. So they have moved it somewhere else or something like that is what has happened. So I'm going to make this one a little bit organized around different things. So the first thing I'm telling you is these are data sources, and they are general in the sense that there is no team associated with them. This InfoChimps is a data marketplace. Some of them, this is true. Data is for sale. So some people they call themselves aggregators or whatever they are, and so their job is to, pull things from different sources, aggregate them, and then they're for sale. So you have to subscribe, you have to pay, and get data. And there are some of them that are free, and so know about it. Go check out and see what they have. There is another place called Numbrary, and so this is numbers, but they are changed into library. Numbrary. This is a catalog for mostly government data on the web. When you go there, you will see what they have. Amazon has a very interesting, and I think they kept growing it, hosts some very, very large scientific data sets, and it is it's a very nice place at that time, at least, to go to get public data sets. This is not like the InfoChimps one for sale. General data sources. I know we have got a nice batch of students here. We've got all kinds of interests and all kinds of backgrounds. For some of you, this is probably not important because you already have data source, and you want to learn about how, what you want to do with it in terms of your own research or your own interests. For some of you, it's the other way around. You wanted to have data science, and maybe you are working on algorithms and things that would need, and you have a need for having to try them out on different things, or you have some ideas that would be worth exploring on for that reason. Knowing existence of data and the different sources you have could be useful. So think of it both as a source for trying out your algorithm, trying out your ideas, or a place where you have a question, a field, a domain where you have a real question to answer. For example, you wanted to see how health and some other things are related, and you really wanted, you have a hypothesis or something like that. And so that's where you're coming, and you wanted to find out about those. That will be a place. So that's the reason for going through this in this fashion. Topical, that was general. Topical. Geography, this I have got personal interest in this, and you have seen part of that reflected in my selection for the guest lecture we had last time. And there is increasing importance to topics like that. Another spoiler alert, your assignment 4 has got something to do with mapping, but you already know that. So geography, things related around locations and what information you would get, what the cell phones these days rely on, what Google does. There are places where you get geographic information. Some of them are for visualization purposes. Some of them are raw data sources. Tiger is one example. This has Census Bureau, extensive data on roads, railroads, rivers, zip codes, and things like that. OpenStreetMap is another place, a good example of data and community effort. This is a place where I want most of you to be active. I know you have more interest than just taking this course in terms of data science. You have your career or your research that would make you, and every now and then you will be reminded there are some good people that do some good community effort, and they contribute resources to R, for example. That's what one happens. But there is also something that you can do in terms of having to contribute to efforts like this, where there is, data related things. Flickr, shapefiles. This is geographic boundaries defined by Flickr users, and maybe you are one of them. I'm not. So you have these topics around geography. Sport, this should interest the vast majority of you. I've got two. They are similar. One is on basketball and the other is on baseball. These are big industries, the data around them. This would have been a place where I would have gone there and you could have clicked there and see what they have. Everything you need to know about all the NBA games, including the players, their scores, or how much money they made, or that type of information around basketball, that type of information around baseball. On the last few years I have taught, there would be always one or two projects students would come up with that have to do with sports. Some of them have deep interest in that sport. Some of them have got inspired by the kind of discussions we have in class like this. This is a good place to just go around, check there, and see what you could do if you wanted to do something that would be an interesting thing related to sports, baseball and basketball. Okay, that's enough. There's also other sources that are still topical that are about the world. The global health facts. This is similar to the kind of thing you saw in that 5-minute video clip we saw some time back about income and health people, that type of information. There is a website called Global Health Facts, and that is a great resource for having to see how different countries in the world are in terms of income, in terms of health situation, access and people's life expectancy and informations of that type. UN data is another place. This is a place where I am not sure if all of the the links that I have now are functional. If they get broken, that means they have moved them somewhere else. But I think most of them are still there. WHO has. Now you probably are overwhelmed by how much attention is given to COVID and things like that. WHO would now have, every place has got dedicated places where you could get more health-related data dedicated for this topic. But in general, they have had this type of things, and that is a place where you can go to check. I'm not sure if I have anybody who has economic interests this batch of students, but I have had every year at least one example. This is a great place to play around with things that are about economic indicators, countries and GDPs and things related around that. The World Bank is another place to see. Okay, now you've noticed how I am treating this. I'm walking you through this, you know their existence, you have an opportunity for yourself to go check out every now and then when you get, and so let me leave it there. And that's the purpose of this soup, the wrap up. Part 3, the file is called part 3, data visualization part 3 is what the file is called, but you will continue with the walkthrough. Topical politics, government and politics. Here is a good range of places where you can see things that are associated with how budgets were allocated or what sort of things went for what kind of things and tracking and things like that. And this is part of the effort that have come out of things that people have championed for a long time to make data available for people. And so these are initiatives, and you can notice that the websites themselves have got this thing that says data in front of it, and then much of the effort is really around that data. Sometimes they are not necessarily very nicely put to people. They're there, but you'll have to kind of dig through things and so on. So they're not very friendly. You would notice there is a difference between how these websites and the data is available compared to the ones that would aggregate and sell you. And so there will be APIs, there will be interfaces, there will be something that is spent on making this. These are more about making them available, but they are very good ones. The fourth one, the one that says follow the money, is I think somewhat related to the book I told you. But this is where people would go to track things and follow and sometimes find out some very interesting things, and you might have read stories around them in the media and things like that. And so you could have your own way to look into things like this, 4 topics that interest you to see how state policies and investigate and things like that. By investigate, I don't mean that you take this one into a full-time job and try to see what everything, no, I meant like on a minor scale, whatever it is that you care about and see. The last one has got, so the names kind of tell you what they are, but the best thing to do is to check this out when you get a chance. Okay, I'm going to ask warm-up question number 2, and this is going to be called confession. And I want you to confess to me, and I want you to be frank. Last time when I told you, I suggested something you do in your lunch break. I said, go to this dataplusscience.com place, and there was something that I told you, and go about and check it out. It was a good half an hour's time that will be good for you, is what I said. I want to know how many of you did get a chance to do that. Okay, so yes or no, I did use my lunch break to browse data plus science. Yes or no, or something like that. So let me call this warm-up question number 2 so that I would know. No, no, yes, no, no, I did not. Okay. I appreciate the frankness, but I feel disappointed that my recommendation was just ignored. That's not a good thing. I really meant it. I want you to go check that out. Okay. All right. Thanks for brutal honesty. But next time I recommend something, please take me seriously and do that. Okay. Data formatting. This is, now we've finished the data sources discussion. The data formatting is because they come in different formats, you have to deal with them. There is a good list here that you probably would want to know. For example, if there is a data source and people have written their names, you would be surprised how many different ways people would write names. They would have, their first name, last name, or they could be last name, comma, first name, all that type of combination. People have taken the time to say, okay, I have gone through this, I have struggled through it, so let me build a tool that would help change names of people, and so they could, have a tool to take care of this data formatting issues and so on. So there are things like that that are available. But my best recommendation here is to go back and look at what the tidyverse, when we were talking about dplyr and tidyr, I told you the RStudio people, and Hadley in particular, did this thing called tidyverse, and there were a few different libraries there, and most of them actually deal with these things, and there is no reason to be spending a lot of your time to do things that are already done. So even if you are working things on Python, you should probably know about this, and then take advantage of those tools that are available that are formatting with associated with data formatting issues. So tidyverse would be what I would recommend. Okay, now we're coming to visualization, and I should watch my time, and if I need to speed up, I will speed up. This is the place where I can actually speed up because we have talked about visualization quite a bit. This is this author, Visualize This Books, kind of category, right? So if you want to visualize something, either do out-of-the-box visualization or do programming. And I'm going to talk about the programming aspect a little bit. And there's other things that you can, that has to do with mapping and illustration. And I will kind of explicitly say what I mean by illustration. So when you have out-of-box visualization, it means you use tool that exists. I'm not going to start with Excel because you are capable of doing other things than that, but there are times that's just enough. But things like Excel, or you could Google spread, many eyes, you will Google it later on and find out what it is. It's a way to encourage many people working together in a way to see things, is what the idea behind it is. Tableau, you have been introduced, is a good way to think about, or one of those out-of-the-box visualization when there is an existing tool. And your flowing data, this is the name of the company the author of the book has, and probably that's one of the reasons why it is there. But it's also a good place to know about when they exist. So you don't have to do your own programming, is the point. It's already there. But for most of you, I would expect you to be doing things that would require you to code. It doesn't have to be very extensive, but you are capable and you have learned enough things now to do that. And so there are different ways. Python will be the vast majority of you that you are comfortable with. And so, here by visualization, I am including things that you need to plot and more sophisticated things. And so all of the things that we have talked about, you could do by having, they may not be very many lines of code, but direct programming instead of using an existing tool that doesn't require you to write anything. So Python, PHP is a programming language that's used for the web. If you don't know it, maybe it's good to know. Processing, this is an open source programming language that is geared towards designers. By designers, I mean those who would care about design aspect of it, and data artists. So it's more of an artist. Some of you may have interest and so know what it is, and so you can find out what it does. Flash and Action Shift is another programming language that is for interactive and more advanced users. And it is used by many of these big news sites. And if you are interested, you can find out about them. I marked R in a different color here because that's what we emphasize in this course. And there is a lot of things that I have said is attractive about using R because it has got much richer libraries and is, in fact, to a large extent, very heavy on visualization and a good use of it. So we did spend one tutorial around it. And you have by now, I think, got convinced that this is one of the best places where you could do. And that I include it under things that you would do using programming. By illustration, I mean things like Adobe Illustrator or Inkscape, and there could be others where you would have something that is, for example, generated using R, but then you want to turn it into nicer things. And so you would have all kinds of improvements to it and the look and things like that. That's what I mean. Mapping is important. Offer's guest lecture was excellent, and so you could use things like that, but there are all things that are already available, and this is a list of knowing them. R has got some functionalities in it that you have will get a chance to work with in your assignment also, but you probably are already familiar. So knowing about these names and finding about what they can offer for the needs that you have is an important thing. I finished these three things, and I'm going to be super fast now on these other ones because we have spent time talking about them. Let me actually back up and then just tell you what we are after, or what I want to do in 5 minutes now. When we visualize, we want to visualize patterns over time. That's one category of things, right? So there is some trends and so on. So time series, that type of thing. The other thing we want to visualize is proportion, second. Third is relationship, and the last one is text information. Patterns over time, what do you look for? Trends, outliers, things that when there was spike and there was dip and things like that. Because I have spent enough time to talk about this and probably is familiar, what I have done in this particular slide is actually remind you what the function names are in R. When you do bars, when you do stacked bars, when you do points, and scatter plots, that's the purpose of this. And when you have continuous points in time, what do? You still use plot. This is, overloaded. And so depending on what is given to the plot function, the thing that you would get will be different. That's the point. Here is a place where I have these leftover slides from different times. And I did put them for you to go back and look at them yourself later on, right? So we didn't have time to talk about them, but I have collected them here. So be ready now. This is another time when you can sip your coffee again. Be ready for 2 minutes or 3 minute walkthrough of 25 slides, okay? So what I will do is flip them around, and if there is anything I want to particularly talk about, I'll talk about it then. But the point is for you to know that it is there and the slides are up, there, so you can come back and look at them. The one thing I want to tell you, which we didn't get to the first lecture, is how important it is to think about bean size when you do histograms, if you wanted to show visualizations. So the size of the bean you would use for this histogram would determine whether you are coming closer to an approximation for what the distribution would be. And there is no good way to know how many beans you would need. And so it would depend on the size that you're trying to show, and how the beans that you would use will be. There is a note in the PowerPoint that I slide that gives you a rule of thumb. I think it is log of the n that you would use would be a good way to find out the histogram size. That was the point I wanted to make. Sometimes your histograms would be better off if you show the density rather than the frequency, the actual numbers, these numbers. So the thing that you see on the left and on the right they look almost the same. The right one is a density, because sometimes these numbers are not the ones that you really, really wanted to focus. And so keep that in mind. I don't want to talk about this. This is not so much. This one is just a reminder for those of you, it has been a long time since you saw Titanic, okay? So it comes on TV all the time. So every time I see it, I can, force myself to watch it all through. And so this is a reminder. Well, that was the context for this one, how many people died in each of these 3 different classes. And if you were not going to normalize it, and if you just wanted to see how many people died, you get the picture on the left. What you see on the picture on the right is when it is normalized. This is a good reminder for sometimes, because the mere numbers are not the ones that are really the crux of the matter. Here you can see how many people survived and how many people died if you were to take into account the class they were in. These are the different decks in that sheet, and so there is a story here, and it could get missed if you were just to look at the numbers of the people. We talked about design, we talked about geographic maps and things like that, and there is artistry that goes in it. This is a very familiar thing. We grew up with this one since ever, we went to school, and people have spent time designing it, and I just wanted you to appreciate it, and then the way how colors are used for a very extensive pack of information on a table. I'm so grateful people like this could come up so many years ago on how to organize elements, and here it is, just a reminder for you to see. This is a place where I want to talk about text visualization. This one is not a leftover slide from last time. This is new, and I have told you there will be some leftovers that are actually leftovers, and there will be some slides that are new. This is among the new ones. Your assignment is going to ask you to do word cloud. Some information is text. There is no other thing to do it. It's text, and we need to have a good way to visualize it. Word cloud is a familiar notion to you, so there is an available, something that you could do in R, and there are some other packages. This is the US Constitution, and this is a word cloud for it. So your assignment has it. I want everybody to be able to do a word cloud, and there is a fun exercise you have in your assignment. The rest of this one, I think I can maybe not flip through. The first lecture we had, I mentioned Taft, and I mentioned about his contribution to data visualization in general, and we talked about good principles and things like that. The rest of these slides have got examples of great visualizations and examples of bad visualizations. So look at them. What are great visualizations? What are bad ones? And the great visualizations are not just about numbers. Some of them are about other things. For example, Napoleon's adventure, this one, his advance and the retreat. And so there's lots of things you can read. I probably would post the PowerPoint version of this one so you can read the story behind it. But there is a number of things like this that are here that you would find interesting as good examples of data great examples of data visualization, and bad ones. And the bad ones, take a look at them so you can laugh at other people, but don't do the same mistakes again yourself. But they are selected from things that actually have happened. They show up in commercials or show up on TV and things like that. And so there's a thing like this that would take you for the rest of the slides, okay? This is the place where I actually want to stop and for us to go to the video part that we are going to watch. So how are you following me? Okay, the video I want us to watch, let me stop sharing, is going to be something that we would want to go to, but I don't know what the best one is. So I'm going to ask for a volunteer. Chris has been good at this. So I'm going to ask him to take us to a place where we'll watch a YouTube video together. And I think if it is played from your part, it will do just fine. So let me actually go to the place where the information is available before I stop sharing. So I told you the good and bad examples and things like that. And here's the place. This is the place we want to go to. The video we will watch is called Data Visualization Can Save the World. It has got very ambitious title, and I like it. And it will take us 15 minutes to watch together. So I think, Chris, you can go to this place and do whatever it is that you have to do so that we can watch the video together. But here's the location. So just you get a time to kind of get it and locate it. Oh, you kicked me out. That's very good. Very kind of you. So go there and we will watch together. I hope this was a good thing to watch for everybody, and thank you for making the time to see it. So I'm not going to spoil what the message was, and so you have heard what that one has. But I am going to, sorry, but I have to come back to business, and so I hope it has given you some thoughts to consider. But I want to talk about assignment 4. Am I going to bore you? I think it's okay. Let me pull that one out. And then I want to tell you what it is and kind of point a few things, okay? So let's go. But you can, in the meantime, tell me what you felt. I'm going to actually ask Chris to go to Blackboard and open it there, because I think that will probably also show you. But is there anybody, what did you think about the movie we just saw? Somebody can say something, either unmute and talk. Great, okay. One more, great, okay. So we've got a couple of grades. So Chris, can you go to Blackboard and open assignment 4 it's posted there, okay. So go to assignments, perfect, assignment 4. Great, so this one is, you remember, I have apologized ahead of time, so don't forget what the video was about, and so you have it in your mind. But we did talk about data wrangling. We started before talking about data visualization, and we had assignment 3, but there was one topic about joins and relational tables and things like that. We had a lecture on it, we had covered it, but we didn't get a chance to exercise, right? So this assignment picks up that one, and I want you not to leave it, so it will make you go through something like that. That's problem 1, okay? Can you scroll down a little bit? So it has got 5 questions, and you would see that it has got 50%. The last portion of that one actually does tie to visualization in a nice way. So it will ask you to visualize something. So let me talk about problem 2 now. Scroll down a little bit. Perfect. Now it's up, no, a bit early. Yes. This one is you remember the last time we had Offer as a guest lecture? I said, where were you born, or where did you grow up? And you typed up things. I want us to create a visualization for this one. So for my first thinking was to Offer to have one of his tools and then have us date. But then I thought that it would be better if you do something on your own. And so for that reason, I turned it into an assignment. So what you will do is, I have the file that's just a Word file that was just a chat analytics portion in the lecture this happened, but I can pull it here and put it along this assignment. But you've got names of cities and state or country. I want you to map this on a world map. You could use symbols, whatever it is that you like. And there is a little bit of guidance, very vague kind of guidance on how you can go about it. If there is any need for me to tell you somewhere else something more to be able to do this, I can provide that information. But this is a research question for you too. If you were to take this one and visualize it on a map, how would you go about it? If you had listened to my advice and you used your lunch break to look at that blog area I told you, there are some things that people, some useful things that you could see. The exercise the fifth part of the first problem tells you a functionality in R that actually helps you to map things out. But the first thing you would need for these cities, wonderful cities in, all kinds of areas in Washington and in some countries, other states and countries, you would need to know their latitude and longitude. So that would be part of the thing that you'll have to do, figure out how to get these coordinates. That all is part problem 2, and it carries 30 points. The first problem with the joints has 50 points. Now scroll down, Chris. The last problem is you are going to do a word cloud. Text visualization is important, but word cloud is one. And so I've got a little bit of guidance on how to do word cloud, but I want it to be personal. So I want you to do a word cloud of thing that matters to you. It could be your research statement. It could be something that you wrote up. It could be some other document that you care about. The example I had in my slide had the US Constitution, which is really nice visualization of what words stick out there. But pick a document you like, but not very long. A short one is good, 2 or 3 pages long or something like that, and do a word cloud. And so there is a little bit of guidance. You can make word cloud look really, really nice. Take the time and make it as nice as you can, but that's probably not so much of a weight on this one. I think anything that you could do with this will be there. These are the 3 problems. This is assignment 4, and this will be due a week from today. On Friday, I'm going to talk about the setup for semester projects. Once we have done that, the rest of the remaining weeks, a good stretch of them will be machine learning topics, predictive analytics, supervised and unsupervised learning, and so on. So you can look forward to that. Thanks again for coming a bit early today. And so you can stop sharing, Chris. We have a couple minutes. We managed, actually. I'm very happy that I got to do what I thought I would do. And because we stole 10 minutes from our breakfast, we were able to finish that. But we have got a couple minutes for those if you have any questions or anything that you'd like to ask or any comments. I have seen lots of interesting things what breakfast was. I'm going to look at them and then tell you what they are, but you have seen them. And for those of you who are yet to have, sorry, that was kind of making you hungry even more. So go get it now. It's okay. And if you have to go to somewhere else, you should do that. Anybody has got any questions for me? Okay. Then if there are no questions, and since we started, I'm actually surprised that we finished this one on time. Okay.
I actually have a quick question. I was looking at the syllabus the other day, and it said, I think it was the 28th, it said that project outlines are out or something like that.
That's what, yeah.
Is that just the list of like the different like project ideas, or is that more just us talking about it on Friday? I just want to make sure I wasn't missing anything.
It is going to be a day when I would first describe what it means for a project, the natures of them and so on. But it will be a day when I would also release project ideas I have. And that document is going to be a living document because I could add a little bit of more things. So it is going to be an important lecture to have, to attend. If I understand sometimes there may be some other things that may, so it's important in that sense, but the document that will have project ideas will be available. And people, you will get a chance for writing proposals for project ideas. So they could be picked from those things that I would suggest or your own. So to have me to say, talk about them is helpful, but the document that will be available should give you an idea for what those projects would be. But the discussion is broader than that. I want to say for example, if you had an idea, when would I call something is broad enough to be called a project? That type of discussion we will have. And that's going to happen this Friday. So the syllabus dates are maybe a little off, I guess. We have made some bit changes, but this Friday's lecture is going to be project setup. And I should probably update the syllabus schedule also because the visualization topic has come. And so there is, what is there doesn't reflect how things have gone. It's close, but there is a change.
Okay, thank you.
Sure. Any other questions? I'll talk about milestones for projects and things like that. Let's save that for Friday. And make sure that you make it. And we're not going to start at 9 and 9:10 is when we'll start. But I will be here starting at 9 as I usually do. All right, have a great rest of your day, and I'll see you on Friday, okay?